the one thing that I would love to encourage you to do is that this session today is being hosted by the ATA, but it's being put on by Dave Martin, who's the president of the Math Council of Alberta. And yeah, active ATA teachers have access to join any specialist council they would like. They can join one specialist council for free. And if they want to join more than one, they can do more than that. If you are a teacher who is passionate about mathematics, I do highly recommend the Math Council. If you have passions in other areas, there are a lot of great councils that you can take a look at. So what I'm going to do just briefly here is I'm going to show you how it is that you would get involved with one of these specialist councils. So when you visit your Alberta Teachers Association page at teachers.ab.ca, you would log in, and to save time, I've already done that for you. Once you've logged in, you can scroll down and you can just hit Specialist Council Membership. When you look at Specialist Council Membership, what's going to happen here is you'll get here to click there to get a membership in a specialist council. If you have a membership in the specialist council, you can join more, or you can change your specialist council membership at any point by using this same feature. So if you're a teacher here who has not yet joined a specialist council, it's part of your ATA fees, and there's some really great benefits to doing so, such as being able to hang out with people like Dave Martin more often, and you'll know why that's a benefit to you after you participate in our session here today. So with that, I am going to turn it over to Dave and allow him to share some of his expertise with you and be able to share some exciting things with math. So Dave, take it away.
All right, everyone. Hey, happy Wing Wednesday. Hopefully you guys I got some chicken wings in the oven or in the fridge. I'm going to barbecue it. I'm doing my own Wing Wednesday since we can't go to pubs and things like that. But you guys excited to get up for everyone who's got yeah, awesome. Some people are like, no, I am not ready. I am not ready. Excellent. Well, we're going to get started here right away. I'm just going to take over the screen, and hopefully you now can see this. Chris will write in the chat here. This is the bit.ly link, so bit.ly/69, capital ABED for Alberta Education, and then capital M on math. So hopefully you can get in there and have this. Also, this is a link here. What questions do you have? Please click on that right now if you want. Ask a question, or is there something you're hoping that I cover? And please fill that in, and Chris and I will take a look at that in one of the times when we do a breakout and see if I can integrate anything else. Okay? So hopefully, Chris, we're good to go in there. Is that all? That's all in the thing? Awesome. So the first thing too is, and I should have done this the other two, I might be talking a lot, but Chris Gonzalez is the man here. So I can't thank Chris enough. I got this picture off Facebook. I don't know if this is copyrighted, but I stole it. He looks great there. But Chris Gonzalez is the man behind the magic here. So I want to just quickly say thanks to him. Okay, let's move on, as we're in middle school now, to one of my favorite parables, and it involves camels. And it's something that I think you could share with your kids to really get their mind going with fractions. And so here's how the story goes. There was this gentleman who loved camels, and he loved math. And what he did was he knew that he was going to pass away. And so in his will, he said, he has 3 kids, 3 sons. And he says, for the son, my oldest, I want him to get a half of my camels. The middle-aged son, I want to get a quarter of my camels. And the youngest, I want to have 1/6 of my camels. Obviously a weird way to put stuff in the will, but nonetheless he did. This gentleman, unfortunately, did pass away. And he ended up with 11 camels. Well, turmoil just erupted among the siblings. Obviously, how do you cut a camel in half, right? So they didn't know what to do. So the three men went to the local village and went to the sage, the smart person of the town, and went to her and said, Miss, what can we do here? What do we do? How do we split up these camels? Well, she said, it's really easy, actually. I have a camel, so I'm going to put my camel in the mix. So now there's 12 camels. So the first one's going to get a half. Well, a half of 12, if a half of 12, 12 divided by 2, that would be 6 camels. Whew. Oldest gets 6. The middle age gets a quarter, so 1/4. So 12 divided by 4 would be 3. So the middle age gets 3. And the youngest gets a 6. Well, 1/6 divided by, or 12 divided by 6 would be 2. And then the sage, she takes her camel back. And everyone's happy. What just happened? All right, so I'm going to leave you with that little puzzle, something to ponder, something to share with your team. The reason I'm sharing this, though, is I think in this digital era, in this whole pandemic, we need to be that 12th camel. We need to come in, do some crazy stuff, get kids really excited about math, and then just sneak out into the abyss. And so hopefully we're going to do that over the next 54 minutes together. I got a lot of information to share, and hopefully I'll go at a pace that's suitable for everyone. But as always, I love starting with mathematics. So get out a piece of paper, get out your phone, get a pen, get a whiteboard, get something you can write on, and let's enjoy some fun. So this is one of my go-to activities when I would go into classrooms, especially from grade 6 and up. And there it is right there on the page. But I think it's better kind of to explain it is I'm actually going to take over the screen on my digital, and we're going to do this task. So how this works is this. I'm giving you the numbers 1, 3, 4, and 6. So 1, 3, 4, and 6. Okay? You are only able to use grade 6 mathematics. So what does that mean? Well, grade 6 mathematics, kids knew how to add. Kids could subtract. Kids could multiply. Students could divide. And students probably know some brackets in there. Our goal here is to use each of these numbers exactly once. So not more than once and not less than once, but exactly once, and come up with every single number from 1 to 24. And we're going to try to do this as a big group. So I'm going to give you a way, first off, when I do this in the class, I think, what's the easiest thing to do with 4 numbers? Well, probably add them. Probably add them. So let's just see what happens. If I take 6 plus 3 plus 4 plus 1, and I add all these wonderful numbers together, well, 6 plus 3 is 9. 9 plus 4 is 13. 13 plus 1 is 14. Sweet. I got a number. So I'm going to go to my other page, and I got 14. So I'm going to cross off 14. I'm going to invite you right now to go into the chat. Just chat anything you want. And can you use the numbers 1, 3, 4, and 6 and come up with more numbers from 1 to 24? Type it in the chat. As I see them coming on, I'm going to start crossing things off, okay? So in the chat, using the numbers 1, 3, 4, and 6 exactly once. All right, Darren, I see awesome 3 minus 1. The problem is, though, you have to use every single number. So 4 times 6, Heather, is great. That's 24, but you didn't use all the numbers. Logan's got it. Logan's got 13. I see a 13. I'm going to cross this off. Kelsey's given us 20. Did she use them all? All the numbers? Yes, she did. 20. Excellent. Ooh, Ryan, I see you got a 1. Good job. Shelly, 19. Sorry if I miss some. Neil, 7. Chris, if I miss a number, yell it out to me. Isla got 6.
We got
Sweet.
2.
This is just straight joy. 2. 16. I'm trusting your math is right. I can't back check
19 and 22.
19 and 22. 19. Oh, 19's done already.
13 and 23. We got
There's
13 and 23.
A 13. I got a 13. I feel like bingo. 6. 12. 12's gone. Yes. 6. What else? What else we got here? A 3. Yes.
I saw an 8. Oh, but 8 doesn't use all the numbers.
Oh, no. 8.
No,
Maxine, you don't have a 3.
Yeah, we got it.
We got an 8 though? Oh, there it is. There it is.
Yeah.
Thanks, Danica. Josh Sherwood gives us a 4.
Yeah.
Oh, Brian Leary. I love what you did there, but we're not going to allow that. That's called concatenate. Concatenate. You're not allowed to take digits and put it together. Brian, that's called cheating. Okay? But good job. I'm just kidding. 18, I see. Woohoo. Let's go. 15, I see. 9, I see. 10, 11, 17, 21, 24. Can we do it?
There's 5.
There's 5. Woo!
Yeah, Kathy's got 5.
All right, we got a 10, 11, a 17, 21, and a 20. Oh,
Vanessa just got 17.
24. Ryan, I love your 24. But Ryan, you're breaking a thing there. You got an exponent. Grade 6 kids don't know exponents. 18, I see. 10, 11,
21. Tracy's got 21.
Ooh, Tracy, 21. We got 3 numbers to go. No one's allowed to leave until we get all these numbers. We got 10, 11, and 24. 21, I see. Awesome. I'm going to go 55 more seconds. There's 11. Woo, we got 2 to go.
12 minus 1. Yeah, that'll work.
11. Yeah.
Oh, there's 10.
There's the 10. 24. Okay, I'm actually going to stop here for a second. You're not allowed to write 24. Oh, Colin did already. Brilliant, Colin. Brilliant. 24's the doozy. I love it, Colin.
Colin, well done.
Well done. All right, we're going to send you a virtual high five. Okay. Awesome. So that activity right there is one of my go-tos, and I think it's just a really easy to get kids engaged, is just simply ask them that, is 1, 3, 4, 6. Now this activity can be manipulated obviously very easily. Give them different numbers. Don't force them to use all 4 numbers every time. What you're looking at actually is kind of a variation of a game called Albert's Insomnia. And so if you Googled Albert's Insomnia, or you could activate this, and this is a really great activity. Also on the bottom of this slide, if you click on more rich math tasks, prepare to be amazed, ladies and gentlemen. 541, 541, 541 problems. Okay, this was co-started by Alicia Burdess, actually a Math Council President X, as well as all these wonderful people down here. And what you will see is 541 different problems. If you have not seen this resource, please keep it now. This is like even the painted cube. What a beautiful problem. If you have not played with the painted cube problem, I encourage, in fact, log off right now and do that problem. That's way better than what I'm about to show you. Okay, one of the coolest problems. All my favorite problems are actually probably found in here somewhere. So 541, it's right there at the bottom, rich math tasks, okay? All right. So I wanted to quickly go through on what I think are my thoughts on essential ideas from grade 6 to 9. Now, please, by no means is this the essential list. I'm probably missing things. Maybe I have some things that might not fit there. But when I went through the curriculum with my own teachers in Red Deer Catholic, and I thought of what are the things they should be focusing on from the middle school ages, kind of, these are the things I came up with. And I want to quickly just rip through them. So solving problems with whole and decimal numbers. Obviously, students need to be able to do that, including order operations, okay? Exponents obviously only get introduced in grade 9, so you would introduce exponents in there. But the thing I want to illustrate, though, is using the use of technology. Here's what I say to teachers. If we're asking kids to use technology, it better be because it's probably you would too. So 32.87 times 62.85, I hope we would never ask kids to do that by hand. I hope we would use technology. 3.5 times 2, probably not a technology question. So I would say is be careful that if you would use technology, we could expect kids to as well. If we wouldn't, then we shouldn't ask kids either. Obviously, square roots, that's an important idea for grade 8 and 9 people. I see the chat box flying up. Just if there's anything in there, Chris, just send me a message and I'll cover it, okay?
Yeah, I will do.
Understand factors and multiples, okay? But I want to talk about this because this is something of a bane of my existence. And this is just Dave Martin ranting. This is please. But divisibility rules versus knowing if a number is divisible. Those are two drastically different ideas. I know in our curriculum in grade 7, it starts talking about divisibility rules. I would urge you to rethink that. Like, let's think about the divisibility rules of saying, okay, a number is divisible by 6 if you add the digits together and you get another number divisible by 6 and then 3 and all that. I think those are just algorithms. What I would rather is have a student tell me, say 305 is not divisible by 3. And it's not because when I add the digits, I get 8. No, 305 is not divisible by 3 because I know 300 is, and then I know 5 more would not be. See, there's a big difference there between an application of an algorithm and demonstration of understanding. So I would just be cautious on those, okay? We'd want students to understand percentages and ratios. And you'll notice I'm using the word understand, not just create, answer, say, naked number questions. And I'll talk about things, how do we get there? Understand integer operations. And then we want some students to solve and represent algebraic expressions, fraction operations, and of course, the big Pythagorean theorem. Oh my gosh, grade 6 and 9. I forgot. We have to do something right now. Get your friggin' coffee cup, get your glass, and let's cheers. There's no more PATs. Woo, woo, woo. Oh, I just got coffee all over. Okay, but anyways, so what's really exciting now is all those not important ideas that we find in our grade 9 and grade 6 curriculum. I wouldn't worry about those. For example, circle geometry. Circle geometry is an important idea in geometry. Don't get me wrong. I studied it in my second year in my undergrad, but they're not going to see it anywhere in high school. And we know a lot of kids aren't going to post-secondary. So just those are the ideas that I would say, as Elsa would say, let it go, let it go. Okay, but anyways, all right. So let's get into doing some math. Let's get into some breakouts. Let's get into some talking. And before we do that, if I had to summarize everything from every grade, what is really essential is number flexibility. I really, really mean that. If students know how to rip apart numbers, including fractions, including decimals, including patterning and put things back together differently, then I think everything else will take care of itself. And obviously, second, but just as important, we want joy. We want kids to love math. We want kids to smile. We don't want kids looking at a pile of worksheets and thinking like, how do I set this on fire? That is not what I want when I think about mathematics. We want kids to be joyful. Okay, so what the other thing is, and as we get higher up, even to send this home, Joe Bowler, if you're not familiar with her, an amazing math educator, she says it best. Students don't fail algebra because it's really hard, as we hear. People say, like, why would you put letters and numbers together? What kind of idiot would do that, right? Algebra is not hard. It's, I think, the foundation of number sense that is. And, you know, we keep piling things on that maybe when kids have barriers in their learning, and we keep putting things on heavier and heavier, and it makes sense eventually they get to maybe grade 9 and it just all falls apart. But it's not the concept at hand they're struggling, it's background information. So I would just encourage you to make sure we always keep that in our minds, okay? All right. Okay, so here's what we're gonna do. I'm gonna give you kind of a possible week plan as we go, and we're gonna give you an example. So Chris is going to, when I say go, he's gonna hit a magical button, and you will be put in a breakout room. And yesterday we did 5 minutes, got lots of feedback. 5 minutes wasn't long enough. So we're gonna up it to 8 minutes. If you were done early, you can obviously just hit leave breakout and you'll automatically be put back. But in 8 minutes, the wonders of technology and Chris behind the scenes will force you back into the main room. So if you haven't already, please get ready to unmute your mic or get ready to talk, because here's what I want you to talk about. I have the question 5 quarters divided by a half. You are, in your groups, you either have to estimate what you think the answer is, explain how you would visualize what the answer is, or simply calculate it. But here's the trick. Every single person needs to come up with a new strategy. So the first person who says multiply by the reciprocal, boop, that's done. No one else is allowed to say that. No one. So the first person who gets to talk, you can say multiply by the reciprocal, go ahead. But I'm looking for some more interesting answers. And the reason is I know a lot of students who multiply by the reciprocal, but when I say, what is that actually doing? Crickets. And so let's see, can we pull that out? Can you even estimate? What does it even mean to estimate a division of fraction problem? I don't know, but have some fun. So I'm gonna lead it over to Chris. He's gonna give you 8 minutes, a hard 8 minutes, and feel free to have a conversation. And if you're done early, focus on what are the great successes you've had in your classes so far. Not the problems, the successes. All right, Chris, take it away.
Awesome. Thanks, Dave. And Dave, just so you have a heads up, there was a question about if we can post the links to the other 2 days' presentations as well. So when they come back from the break, we will have that in the chat for you. So we will have yesterday's and Monday's presentation links there for you as well. So
I will actually add that on my final slide.
Awesome. Thanks, Dave. Appreciate that.
Yep.
Here we go.
Early on grade 6 and 7 teachers, something to think about is how often do we get kids to skip count by fractions? Like, what if you skip counted by 2/3? What's the pattern there? What a beautiful, beautiful way. I don't know if you can hear in the background, but we're exercising our middle kid. I might have called her an inappropriate name right there. But yeah, I'm learning that every morning, I don't know about you, I have to wake up and remind myself I love my 3 daughters. So hopefully, anyways. Going back to this beautiful problem. So I have 5 quarters, and then you can see that I have this thing here that kind of, it actually is half. Now, division to me is, some say it's repeated subtraction. To me, it's this. I actually read it the opposite way. I read it as how many halves do I need to make 5 quarters? And so if you see, I take 1/2 and I drag it over. Okay, well, that's 1, and I still have some more left over. Okay, let's grab another one. Bring it over. That's 2, and I still have some left over. And I bring over the 3rd one, but did I cover too much? Yes, I did. How much of this last blue square am I using? Hopefully you can see it's exactly half of it. So when I count, I used 1, 2, and a half. So the answer is 2.5, not because I multiplied by the reciprocal. I mean, you do get 2.5 the same way, but it's 2.5 because 2.5 halves make 5 quarters. which I think is a very important idea that students still need to understand even in this digital era. And so whether you are doing this in the classroom or not, what I would encourage you is we have to make sure the research of going to abstract ideas is definitely followed in the online world. Meaning we know from brain research that if we want students at abstract here, we can't start there. Abstract ideas stay there as just simply these kind of unknown entities to kids if we start there. What we do want is kids to have things in their hands. Totally agree. It's probably impossible to get manipulatives home to every single child at home now. I get that. So maybe what I'm going to say is maybe we really start our work here in this representational mode. And that's what I'm going to be focusing on for the rest, is hopefully that if you focus here, the abstract takes care of itself, okay? And to illustrate that even kind of another way, I'm going to actually do something abstractly, and then I'm going to do it visually. And I'm going to ask you which one makes more sense to you. So just in the chat box, anyone, what kind of numbers do I have here? What kind of numbers? Just anyone just rip in the chat. How would you describe the numbers I have? Prime, I hear, okay. 9, I agree, some of those are prime, but 9 isn't prime. Ooh, odd, good. Yeah, they're odd numbers. So 1, 3, 5, 7, 9, 11, 13, so on. Ooh, that's a fun game counting by odds. But anyways, there you go. So what I'm gonna do now is I'm gonna take something and do it abstractly to you. And then I'm gonna do the exact same lesson again visually, and hopefully you understand the difference in the power of visualization. So imagine we have these 1, 3, 5, 7, and I just look at adding some of them. So let's see if I have these beautiful numbers and I start adding them. Well, if I take the first number, I get 1. Not very interesting. Margaret, I'm going to talk about the app I'm using and everything all at the end. I just thought it's opposed to just going through it as the time. I'll go through that at the end there, okay? So the next thing is I'm going to add, say, maybe the first 2 numbers. 1 plus 3. Well, 1 plus 3 is 4. I don't know. Maybe interesting, maybe not. I don't know. Let's keep going. Let's add 3 numbers. 1 plus 3 is 4, plus 5 is 9. Rob M's got it. Perfect squares, baby. Perfect squares. 1 plus 3 plus 5 plus 7 is 16. Add the 9 in. You get 25. Okay. This lesson is very abstract. So Rob got it, and some of you who also acknowledge that 1, 4, 9, and 16 are perfect squares might also have seen that. But now what I'm going to do is I'm going to give you the exact same lesson visually. And hopefully this makes a little more sense. Imagine I take the numbers 1, 3, 5, 7, 9, and I build them, as you guys said, oddly. So here's 1, here's 3, here's 5, here's 7, here's 9, and here's 11. Watch what happens when I go 1 plus 3. I get 4, a perfect square. Add that to the next number, a perfect square. Add it to the next number, a perfect square. Add it to the next number, a perfect square. Add it to the next number, a perfect square. They're perfect squares because these numbers actually form squares when made out of blocks. I don't know if you've known that. Perfect squares like 16 is because I can actually make a perfect square. With this, the moment you do this, then you ask kids, what are triangle numbers? What are numbers that would be form triangles? And this is a perfect way that you can integrate some of those non-essential, and I don't want to say not essential, but less important maybe, I don't know, like patterning. Having kids just talk about what's the pattern, probably not as useful. But using patterning in this kind of sense and saying, when would be the next perfect square? Or what would be the next triangle number? Or what would be the next hexagonal number? Or, and so on. I see vertices and so on. Excellent. Beautiful. Yes, the 4-year-old knows number blocks. I love it. I love it. Good. Yes, good call, Tara. Okay, the next thing is Math for Love. If you click on this, this takes you to an entire lesson plan used by this number. I don't know if you know Dan Finkel, but this guy created this beautiful board game called Prime Climb. What you're looking at is the beautiful representation of multiplication. Like, this is art, ladies and gentlemen. Like, this is a tattoo. Everyone should have this tattoo. This is just outstanding. Like, and I'm going to go through this. I'll show you how awesome it is. 6 times 2, we know, is 12. 6 times 2 is 12. If I look at 6, it has an orange and it has a green. 2 has an orange. Put them together, orange, orange, green. Oh my gosh, this is crazy. If you click on the link, you can actually get a hundreds chart that's kind of broken into this. And what you can actually do is have kids create their own multiplication tables at home. What you're seeing is kind of mid-work of a couple students creating their own multiplication tables. And I think this is a way more useful tool than a 10 by 10 grid. If you want to know where these are, just click on the link that if you look at the picture, just click on it with your mouse and it will take you to an entire web page, okay? So if you haven't seen this before, I definitely would encourage you to start here with multiplication. This is really prime number factorization. This is multiples. This is factors, all in one beautiful coloring page. And who doesn't love to color? Like, let's be honest, coloring is the best, okay? The next thing is, excuse me, is let's look at this lovely picture. This picture has like some kind of bump to it, and then some kind of hole, and the bump goes in the hole and it makes a line. Two bumps and one hole makes a bump. Interesting. In the chat, what do you think this would be? A bump, a hole, and a hole. If I was to simplify that, as you will, whatever the heck simplify means, what would that be? Yeah, it would be a hole. It would be absolutely a hole, because this would fill with this, and that's a hole. This bump fills with that hole, making this a hole. You are playing with integers, ladies and gentlemen. This is integers. This is a beautiful way of integers. This is a visualization of zero-sum pairs to show that +1 plus -1 is a 0. This right here is 1 plus -2. This is -1 plus 1 minus 1. And this is, of course, is 4 plus -2. If you love this and more, James Tanton, an amazing mathematician, has created a whole book, Math Without Words. But if you click on this link here, it will take you to a whole, link of a whole bunch of resources. This is another way to get kids visualizing mathematics. And to them, they're really working on a puzzle and playing an activity, as opposed to kind of working with integers, which doesn't sound as interesting, but we all know it is, okay? The next one is this, I call them dice chats or unit chats. What I want you to do in the chat right now, here's a beautiful picture of a bunch of dice. What kind of numbers do you see? I'm going to go 2 minutes, 120 seconds. Just type in the chat box, what kind of numbers do you see? So for example, I see a big 5, a ginormous 5, a dot here, a big thing here, a big thing here, a big thing here, and a big thing here. I see these dice organized in a dot picture of 5. Cool. Carolyn, sorry, I took yours. I took yours before you had it in the chat. I see 4s and 6s, consecutive numbers in small arrangements. Cool. I see numbers, doubles, 5 groups of 4. I see 20. Look at this beautiful 5 4s, 18, 20. You're literally doing multiplication without maybe knowing it. I see students once that I where the students were saying there's a 4 up here and a 6 down there. That's a 10. A 5 and 5 is a 10. A 5 and 4 or 6 and 4 is a 10. A 5 and 5 is a 10, and all this. And so if you click on the bit.ly/count for me, and I saw that Chris also put the link in the chat box, thank you, sir, this will take you to a whole bunch of pictures. Now with you guys, unfortunately, you're after the fact that students would have hopefully memorized multiplication. In grade 8, I know that we need kids to know their 9 times 9 tables. Fun fact, not everyone knows their 9 times 9 tables, right? That's a reality. So what I do want to caution you in, though, one of the bad practices, and I don't think we do it intentional, but the research is evident, giving them a 10 by 10 grid with 100 numbers on it is very confusing to kids who don't really understand multiplication. So Dr. Nikki Newton did some work in this, and she actually has kind of a progression, if you will, for those who need to do their facts but don't actually know them. And this is the progression she said would follow. First, get kids to multiply by 0. Obviously, I've missed out 0 purposely, but I would hope kids know 0 in middle school. If not, that's where you would start. But 1, 5, and 10. After they can multiply any single digit number by 1, 5, and 10, we move to 2, 4, and 8. Then we end with 3, 6, and 9. And of course, the only number left is 7. But really, you would have covered 7 along the way. So the only fact you need is 7 by 7. But let's be honest, 7 isn't important. Okay, I'm just kidding. 7 is the bane of everyone's multiplication, right? You want to see someone freak out, say, what's 8 times 7? Oh, hives, okay? Anyways, after doing these, what you can do is ask them to create their own. Could you create your own dice picture? Awesome way in these, you can integrate fractions, you can integrate symmetry, you could integrate algebra. And then, ladies and gentlemen, for you is imagine we take a pattern idea and mix it with a dice chat. You have this beautiful picture here. So here would be another opportunity that maybe on a Monday or a beginning of a day, you show them this. You say, I've actually created a dice chat, but it's part of a pattern. What's figure 1 be? What's figure 3? 30 seconds, type something in, right in the chat. What do you think figure 1 could be? What do you think figure 3 could be? What is the thing that's changing in the pattern? What's the thing that's remaining the same? Ooh, awesome. Awesome. No ones, just the ones. When you divide, you get the white dice. Oh, I didn't even know that. When you divide the values of the blue dice, you get the white. That's awesome. Okay, cool. Excellent. I see all these ways. Good news is you're all wrong, okay? I'm joking, but you're not. I'm not. You are all wrong, but I wasn't trying to. But the reason I do this is that I wanted to create a pattern that no one would have probably have guessed. Here's why. You all differentiated on, I guess, what you thought would be that's applicable to your level. So kids who are really, really creative, we might see patterns being very creative. So kids can self-differentiate. The next day you say, okay, everyone, I loved your patterns. Here's what Chris thought. Here's what Carolyn thought. Here's what Logan thought. But actually, here is really what pattern 1 was. And now what we've done is we've taken kids who have all differentiated themselves and regrouped them now and said, okay, now pattern 1 is here. And you'll notice that actually it was a geometric shape that I was changing. Here is now a beautiful way to cover shape and space through an essential outcome lens of number sense. So when I ran this, and I'm going to be authentic, I haven't run this online as I'm in a math lead position. I did run this in authentic classrooms, and the conversations of kids using triangles, squares, pentagons, hexagons in authentic sentences was beautiful, as opposed to giving a worksheet saying circle the hexagons, because that's a lot of fun. Okay. So after this is we say, okay, here's figure 3. What kind of shape is that? But then we could ask these questions. What about figure 5? And then we know what figure 5 looks like. So that's not really interesting. What's interesting is, what's the total of dice on number 5? What's just the number of dice on number 5? What's the area in the middle? And what I actually had is we had students exploring what's the area in the middle going to become more and more like as we increase the number of dice. And if you think about this, if I had 30 figures going, the middle of the dice would be kind of a circle. Huh. What a beautiful way. And I know someone wrote up in the chat, and I wanted to say that circle geometry is beautiful. It is beautiful. I didn't mean to say it wasn't. What I meant is, let's not, if kids are struggling with inscribed angles and those things, I think are better things we could be focusing on. Those who think those things are beautiful, please still give it to them. Do not hear me say, oh no, if someone finds it interesting, they're not allowed to learn it. That's not what I meant, okay? I'm more talking about holistically and keeping your sanity. Okay, so hopefully that makes sense. I see that. We can do visual algebra. I don't know if you've ever seen this, but this is a beautiful way. You draw a picture and then you say, what's the equation you see? So what equation do you see in that when I have a picture? What expression or equation would you might create to solve for X? The reason, as we were saying this, I'm not a big fan of algebra tiles. I'm going to be perfectly honest. Dog's out, okay? It's not that I don't like algebra tiles for visualization. What I don't like is X is always this length. So sometimes this is 5, sometimes this is 7, and sometimes this is 9. That's crap, because 7, 5, and 9 should all be different lengths. But algebra tiles, I get it. They're manipulatives in their hands, so they can't do it. I don't like using algebra tiles for equations. I think they're great for expression. It shows you similar terms. But for solving equations, I don't like it because you can't really manipulate it. I see some people, though. Now, what you've just seen in the chat are what we call equivalent equations. All that work's done for you. Show a picture to the kids, have them do a Padlet, have them do a Mentimeter, have them do a poll anywhere throughout the entire day, because we're all synchronous now, asynchronous, so kids can be doing it whenever they want. And then the next day, you throw up all the expressions or equations, you say, which one doesn't belong? Which one is not right? How is, and I see this now, how is 3x minus 3 equaling 21 the same as this one? Or is it? Did someone make a mistake? And so now what you can do is like really crowd, I guess, get the answers from all your students and then throw them back at them to have a conversation. Oh my gosh, we're 17 minutes to go. Holy, okay, I got to go a little fast. Okay, I apologize. All right. My new zombie cup. Okay, the next one is this, like even this, those who start struggling with number sense. The reason I love this is the kids who are struggling with whole numbers will use whole numbers. The students who, whole numbers are boring, they're gonna start using decimals on the second one. Maybe this is 3.5 times 5, and how would they figure it out? What I see is these are strategies that kids self-differentiate for, meaning they go where their strengths are and they push themselves. But what the student creates as a question tells you a lot about their understanding at the point. Okay, hopefully that kind of makes sense, all right? All right, next thing you could do, broken calculator. Oh my gosh, this is just a whole joy of fun. You're seeing a picture there where a calculator, some of the buttons broke. That's weird. I don't have a 1, I don't have a 2, I don't have any of these, a 0. I don't have a decimal. What buttons would you push to make it? Okay, so how could you make 21? Sure, we can go 7 times 3 is 21. That works. What other things can we do? And what we want is some questions that you could ask follow-up is, how many ways can you get the gold? So 7 times 3 is an interesting answer, but is there other things we can do to get a different answers? The next one is, as a mathematician in me, I want to say is, oh, when I see 9 plus 8 plus 4, awesome. What is the least amount of keys that needs to be pressed? Well, how could I do that in the least amount of keys? Now, 7 times 3 might be the answer in this case, but as we go up in more difficult problems, that becomes a little trickier of a problem. And my other favorite is, I criticize textbooks a lot about this. Kids are always working on problems that are solvable on a textbook. That is not reality in mathematics, okay? When I worked on my master's, I had to work on problems that I didn't know how to start, didn't know what to solve. I didn't even know if there was even an answer. I want the same experience from students in a very joyful setting. So how do we start them getting there young? Is we ask this question: what number can you not make? Using that broken calculator, what can you not make? Can you not make a 1? And how do you know you can't make a 1? So you see, it's flipping it reverse. I don't want to know what you can do. What can you not? And I think we'd agree that's a higher cognitive task. You increase the cognitive, I guess, ability there. So if you want, there's an online game here. You can play this. This is just a great Friday night. Get a glass of wine, play there, see what level you can get up to. That's fun. Lesson plan here. So there's a whole lesson plan. And there's even a video of seeing this in action. Yes, unfortunately, this video was before COVID-19. So it is in action in a classroom. But hopefully you can still get the kind of feel for it, okay? Hopefully that makes sense. Ooh, a few tequila shots. Megan. Yeah, that's great, eh? If you can't get it, do a shot. Okay. Oh, crap. This is being recorded. I didn't say that. Okay. Anyways, moving along. So the next one is, how about open middle? I don't know if you've seen this before, but open middle kind of has a Sudoku feel to it. You're actually seeing now on the right side is a question that junior high teachers in my own division we worked on and created. Here's a perfect example of how do I integrate some of those other outcomes that I know I have to cover. I have to cover perimeter and area. But I don't want to just have a perimeter and area worksheet. That is boring. So here's a way that I've integrated monomials, polynomials, perimeter, and area all at once in a beautiful question. You have to create the sides of this rectangle such that the perimeter and the area and the side lengths never have a repeated digit. Never have a repeated digit. Oh, think of the joy there. Now, I see a lot of people saying, I love open middle. I get it. I love it. Okay. My next challenge for those who are already using it, for those who aren't using it, start using it. For those who are using it, my challenge for you is, what if we had kids make some now? Can you make a problem? The other thing I said, and I've been saying this a lot, is I like using the words best or coolest because I think those soft words create that any answer can be cool. But I want to know why you think this answer is cool. Because there's a lot of trivial answers and sometimes in open middle problems, and I'm not really interested in those. Okay. How we do? Ooh. Okay. Next thing is fractions. Fraction talks. I don't know if you've ever seen fraction talks, but I'm going to go there right now. If you click on fraction talks here. And what you get is a beautiful, beautiful website of a whole bunch of different fractions. If you've used these, you probably already know the power of them. If not, I would strongly encourage you. Like, look at this awesome picture right here. Throw that up on a Google Classroom, throw that up on a picture, and ask kids the following. How would I shade it in and show me certain fractions? And again, I love the question is, what do we do if we, or what fractions can we not make? Now, that might be a trickier question on this because there's an infinite amount of fractions you can't make. But still, just something, an idea. Like, is it easy to make a third in this picture? Is there easy to make a fifth in this picture? Things like that. Those are the kind of the activities that I would have kids. And literally, they can just color it, either digitally or maybe just even reproduce this picture on a piece of paper, take a picture and submit it to you digitally. And so that's another way that we could engage kids. Okay?
Hey, there's a really great question. Yeah. From Caitlin saying, what about students who aren't really willing to try these types of questions? Any suggestions or help, and how do we encourage our students to try these types of questions when maybe they're a little bit more reluctant?
Yeah, absolutely. So you're going to notice, you're probably noticing the, I was going to start with the graph, right? Where engagement was probably going like this and then, right? And like, cause novelties run off, like, and they're like, holy crap, I actually have to do work. So I get that. My challenge for you is I would do it the same as in an authentic classrooms. I would try to first maybe interact with them in a Google Meet setting. I don't know if that's possible in your timeline, but try to do a one-on-one. But the best thing you can do is make sure math is not the barrier the first time we do these. So when I go back to this problem, let's go back to the open middle problem. this is a lot to unpack. Like, okay, I have to use digits 0 to 9. I can't repeat. What is all that? So you know what I would first do is just simply create an addition problem that has no repeated digits. 1 plus 2 equals 3. Sweet, you got it. What I'm doing now is I'm trying to take the barriers out of them, and so open middle is the only barrier. That might also be the case there, Caitlin. I mean, from kid to kid, it's always case-by-case examples. But usually kids who don't want to do it, it's because, and I love the line, no one hates math. They're just tired of being embarrassed by it. And so we want to make sure that we're not giving problems that, you know, I see it all the time when I do parent nights and I ask questions to parents, like, can you visualize division of fractions for me? And the parents, like, they just vomit in their mouth. They're like, I don't want to do that. All I know is the algorithm. Don't you dare ask me to do anything else that I don't know what to do. It's not that they're intimidated by math. They're just confused and don't want to be embarrassed by it. And so what we have to do is be careful in that. Let's bring math so it is accessible to all levels. I mean, again, if they're not engaged with something like kind of unique fractions, then start here and just say, here's what I want. I want 5 cool ways of showing me a half. And I want every one of them to be drastically different than each other. I'm starting with a half because your question, you said it was in grade 9. If grade 9 was, if that's 2 advanced half, well then, then keep going down and down and down until they feel success. Early ages of success is one of the key points for intrinsic motivation towards concept. And so we want to make sure we follow that research. That was a very long-winded answer, Caitlin. I don't know if that made sense, but that's anything else? Does that kind of make sense on those ideas? Okay. All right. So going through this, decimals on a number line, this is a beautiful activity. This is modified. We ran it in classrooms. It's awesome. It's rolling dice and games and trying to put decimals and fractions on sign and ordering. It's a really activity. I won't go through it because you can click on that. Same with fraction talks, all this. These are great activities to have visualization. Again, I would be doing, please do not hear me say you would do this all in one day. Each of these would be a day. So broken calculator might be a day. Okay, we don't want to overwhelm kids either. The other thing is we have to be careful of equity at home is a very, very big problem right now. I work with some junior highs where, you know, the families have 6 laptops for 4 kids. So they can like do dual screen. The kid can be watching a Fortnite tutorial while doing his fractions. The other one we have is where I've seen 1 Chromebook among 4 kids. And so that becomes problematic. And so with these is try as best as you can. And I saw it earlier. How do we take less techie ideas is just submitting this. This could be easily drawn. Right? And then once they have it on paper, they can reproduce it and do whatever they want with it. Okay. So a day being how long time-wise? We have 2.5 hours per week. Yeah. So Tara, I would say that about a half an hour a day. Like I would say 30 minutes. Like, and again, 30 minutes of math a day, it's a lot. Like it is, among with all their other concepts and other courses they're covering, right? We have to remember that middle school kids aren't just doing math. I wish they would. Like social. The only reason they need LA is so they can read a math problem, really. Okay. Okay, anyways, skipping right along. Okay, so the other thing is too, is make sure you plan for joy. Make sure you plan for fun. And I don't mean like, yes, sometimes just having fun is fun on its own, but I really mean this, that if kids always think it's math is this kind of abstract idea, then we sometimes lose it. Here are some awesome activities that I just said that I think kids in the middle school range would find very, very engaging. Anywhere from skyscrapers, where they're actually building skyscrapers of different heights and trying to put them in a kind of Sudoku-sized puzzle. Logic mazes, like these are, I just showcased these yesterday, but logic mazes are great. You can't do left turns. You have to use the number. So if you're at a 2, you have to move 2 spots. Again, I won't kind of go through all this with you. You can definitely click all those links on your own. Kenkens, Yohakus, Zuki. Oh, Zukis. I actually do have to showcase this. For those who like the 3D spatial awareness puzzles, these are wicked, wicked puzzles. So how these work is, again, this is just a way that you have to, using only the dots given, you have to make a square. So you can see that if I connect these 4 dots down here, I would get a square. Very easy, but as they go up, they get more and more problematic. How would you make a rhombus? How would you make a parallelogram, trapezoid? The reason I like this, it comes from the stance of a puzzle, not as a kind of like that worksheet feel that doesn't have it to it. So I love these kind of puzzles too. So again, I would make sure that we want to, and I would say, I was saying to my teachers, do them Fridays. Do them as a puzzle Friday with a twist. Then on Monday, you're coming back and sharing how you did it with your family. I think at this time right now, we have to be very careful. Imagine homework, and I'm not saying don't give homework, but I would encourage you to try to give homework that engages students with their family and home as opposed to school and the community, okay? So make sense of, hey, mom and dad, maybe you're gonna make a dice picture and you're gonna see, and you and your mom are gonna sit down and see all the different numbers you can make. There's a difference between engaging at home with the content. Hopefully that kind of makes sense, okay? Also, I don't know if you've ever seen this, but these are amazing problems. So these are called pickle problems. When you don't know what to do, put your students in a pickle. All right, pickle problems. What these all are unsolved million-dollar problems, ladies and gentlemen. When am I going to use this? You say, do you want $1 million? That's when you're going to use it. All of these problems are accessible anywhere from all the way down to grade 1. And if you go through them all the way up to grade 9, and it talks about and all of these have some sort of unsolved problem to it. But it gives a really cool way of integrating it and letting kids of higher grades play with these kind of problems, okay? So unsolved K-12, that's an awesome one, okay? So there's all that. Hopefully that's kind of making sense. Okay, what do we got for time? Oh, we got 3 minutes. All right, so these are some other things. So someone has already asked me with technology. Your higher end now, it's the students, if they do have Google at home, I would definitely advise you to get the add-on Equatio. I know we have done, when Chris and his team have ran Equatio webinars before, and so he will definitely, with the link that he gives you on the ATA PD resources, there's going to be videos on that. But Equatio is this little lovely blue button you're seeing right now up in my top right corner. It was what made me able to do this visual math, or not visual math, the kind of math that I gave. Can't find the slide now, but the question where it was 5/4 divided by half. That lets you type in Google Slides, Google Docs, and so on. The other app that people asked, I'm using the app called Show Me. So when you have Show Me app, is you actually, kids can record, they can do video, they can do pictures. It's free. I love it. You can do slides. The other one is Explain Everything. I'm just going to caution you on that one. If you're using the free version, it's not as good. If you want to pay for it, so it is a little bit of a price, but it is amazing. So I don't know if you have access to some funds. Maybe you can get your principal to pay for that, because funds are just so readily available right now. But anyway, sorry. But yeah, I would do the Show Me first and start. The next one, template for math talk. So what I showed you before of using those division questions is this is a brilliant way of getting kids to kind of communicate their thought through a kind of a template. Mobile math is great. If you click on this is an awesome algebra way. So in a game-based form. So there's all these different levels. I'll click on just this random one. And so this is telling me these things are balanced at 18. So I know that maybe each side is 9. And then I have to do some math to figure out what are the hexagons and what are the moons. And so again, this goes as the higher level you go up, the more advanced it gets. Okay. This is a great date night activity. Awesome. Awesome. Okay. The next thing is Desmos. Oh my gosh, Desmos is great. If you haven't checked out Desmos Polygraph, I'd invite you to. You can click on BedMass. This is a polygraph I made. So when I say polygraph, I don't know if you remember the old Guess Who, where you'd have all those faces in front of you, and you would say, Chris, does your person have glasses? And he would say, no, he does not. And so all the people with glasses or without glasses, I would put all down and I'd have the remaining people. Hopefully you guys know what I'm talking about. What I created was a digital version of that, but with BedMass. So when you click on that, you would click as simple as going through this. And I don't want to, in case this is more, if you're scared of technology, maybe don't use this, but it's very easy to do. You would create a class code. Kids could ask questions, true and false questions. So one person picks one of these and they're played against someone else. What I love about this is you could do it digitally, but you also could just literally give these people the cards, have them sit down with their parents. They mentally just pick one in my head and we ask yes or no questions. And so this is another way you can engage kids either digitally with each other, because I could actually you can play with anyone across the planet on this, okay? But if you want to see more of Desmos activities, I would go to teacher.desmos.com. Okay. Also, if you click on this link, this takes me to all of my gems I have ever found in the 5 years of working in my position of a K-12 math lead. So I'd invite you to click through all that, just explore. Okay. There's lots of stuff there. It's going to feel like drinking from the fire hose, but that's okay. One thing I just want to end with before any questions is this, and you guys have a special one on this, but we're not doing online teaching. I hate when people tell me we're online teaching. We're not. We're literally trying to survive among a pandemic, critical funding cuts, and unknown timelines. So what I do, though, want you is this. I want you to ask yourself, what else can you let go? Like grades. Are grades important right now? AEC left out a brilliant idea that maybe grades are a time we leave them in the past. I would encourage you. I would not be worried about what's the difference between an 80 and a 90 in my grade 9 math class right now. I would also ask you, what are you going to do for final exams? Because we know the validity of any digital test is going to be in question. So how do final exams look? Maybe we changed it to celebration of learning, where what I want you to do is submit to me a 5-slide Google slide presentation of the 5 coolest things you learned this year. Something that can't be really cheated on. Summative assessments. Now, I say maybe get rid of all those, but I would encourage you never, ever, ever get rid of feedback to kids. Kids don't need final exams, grades, and summative assessments to learn. They don't, but they definitely need feedback. Everyone does. And so I would encourage you to, how do we go from that mode to the next, okay? I've given a lot of stuff at you. For those who asked for the links, so yesterday or 2 days ago, we did the K to 2, we did the grade 3 to 5. Hopefully you can see the pattern. 10 to 12 will be the exact same thing. It'll be 10, 12, AB math, okay? If you have any questions, you can email me here. Reach me out on Twitter there. Also, Chris Gonzalez, I should have put his information in here. He is really the star of all these, doing all the work in the back. He's the marionette. I'm just doing this with like strings, okay? So please, I'll stick around if you have any questions. Reach out. I've gotten some emails. I'll definitely help as I can. But hopefully you got something out of it. Go wash your hands and have a beautiful day.
Awesome. Thank you so much, Dave. And I've had a number of people asking about where do I find the copy of this after. We're recording this for you. So I'm going to pause the recording right now or stop the recording right now.